So let's see to a GHG problem, permutation of a string. So what question says that you will be given a string S which may contain duplicate characters. Like it can have a duplicate character, like A could be 2 times. So what you have to do, you have to return all the permutation of ABC. So what does permutation means? Means the length of what the S is should remain same in the output, but the ordering could be anything. Like if ABC, so its permutation could be BCA, CBA. So you can do anything you want, just you have to maintain the frequency of every character same in the output. So if that is take care, then it will be a permutation of one such permutation of this string. So what this input is like ABC. Here are all the permutation possible for it. So let's see how to do. So we could think of something like the recursion we can do with it, but this could give DLE. So let's see if the constraints is what like it is 9, so it won't be giving the DLE, because even if there is an option for every, like you can pick any ABC at first, then at a second time you would have, like suppose the length of the string is 9, in first recursion call you will have 9 call, and the second you will have 8, and then 7, then 6, like it would be 8 factorial, 9 factorial. So basically you have 9 factorial complexity, which would be less than 10 to the power 6, so you can do it. So let's see how I have write the code. So what I am defining a set, it will contain all the permutations that will be generating in the set. Why I am using set? Because there could be a repeating permutation, like if the character is repeated, like A is 2 times, so permutating 2 character having which is same would result in same permutation, so it will take care of the duplicate. And then any size, I am just defining a visited vector, which means that while recursion I have to maintain what are the element I have picked, and I have to not pick it again. So for that I have defined a visited, and then I am calling a function that is basically a recursion. So these are the count is basically the number of the element that has been added to temp. Like it can be eliminated by this can be used like temp dot size. It will be count will be equal to temp and minus temp dot size. So you can eliminate, but I am keeping count, so as to make it simple. Count is basically the number of the element that has not been in the temp string. Like initially the count will n in the first recursion call, when it will call, and I am just decreasing count by 1. It means the count has become n minus 1. It means that n minus 1 element has been remaining, so as to put in string temp. So this recursion call will go until the count becomes 0. 0 means 0 element has been left, and n minus count has been put in the string, means all the element, if count is 0 means all the element has been put in the temp. So this is one possible permutation I am just putting in our set, and just at this point I am returning. So the main point to take care of that is like here and this I am visited, I am marking 1, but once the recursion call is completed and this goes down, then we have to again mark it 0, because after next for every recursion call there should be different visited possibilities. So once this recursion call is complete, we have to undo the changes that we have done in the starting, so as to make one such permutation. So I am just popping the last element that I have pushed in the string and reversing the visited parity. Like if it is 1, I have make it 0. So this recursion call will generate all the permutations regardless it is unique or not unique. That will be taken care by this set. So at last what I am doing, just iterating the every element in the set and pushing the string of that set into a vector of string, and at last I'm just returning vector of a string, as given that order doesn't matter, so it will be in any order. We have to just push it and return it.